Hi, all of you. The subject I'm going to deal is HVDC transmission, Chebron College, Chebron Department of Triple. So the total syllabus I'm going to discuss. First of all, we go for first unit. Previous have covered the syllabus. Today's class we're going to unit one. The topics covered in this unit one are basic concepts of HVDC transmission. In the previous offline class we have discussed that what is need of HVDC transmission, why we go for HVDC transmissions in India, right? We have several regions are there: central region, northern region, it is southern region, and etc. Right? Coming to because of frequency does not frequency links and frequency does not match, so you cannot directly connect the high transmission line between the two regions, right? One of the region, and second one is for a high distance long distance transmission, so we go for HVDC is economical, right? So these are some advantages are there. Deeply we go for a discussion in the unit one. There is basically concepts and topics are economic and technical equipment used in HVDC transmission system. So what are the types of HVDC links? HVDC links means previous concepts actually in the AC transmission. We have single phase, three phase like that, but here also some types of there for transmission the power from one to another stations. Types of HVDC links, right? Next, coming to next one is operators required for HVDC transmission and comparison of AC and DC transmission and applications and planning and modern trends in DC transmission. These are the topics covered in Unit 1, the syllabus in the Jntuk Kakinada. The topics covered in this first unit are these are the things, right? And coming to first topic, we will go for introduction. Right, historical background, right? Unit 1 introduction. So a high voltage DC current, HVDC nothing but high voltage DC current, right? Electrical power transmission, HVDC power transmission, also called a power super highway or an electrical power highway, right? A simple name, it is just name. Uses actually the high voltage HVDC uses direct current for bulk transmission of electrical power in contrast with the more common alternating AC transmission system, right? So actually, mainly we go for why HVDC transmission means for high voltages. For high voltage transmission, we go for we can test the high voltage in terms of HVDC. Okay, so for transmission the power, right? So for long distance transmission also, HVDC system may be less expensive and suffer low electrical losses. So simple point I have covered here. For long distance transmission, HVDC system may be less expensive and suffer low electrical power losses, right? Means long distances means uh, actually for short distance HVDC transmission system it should be high expenses. One of the disadvantage for HVDC transmission system is, so for short distance transmission it is very expensive because there is a technical equipment used in this system, so that is a rectified unit or anything. Okay, so for that but here he said that for long distances means above 500 kilometers HVDC system is very less expensive. Because the what are the reasons? Let's go for next discussion actually in the just remember that point. For long distance transmission HVDC system may be less expensive and also suffer low power losses, right? So for underwater power cables, HVDC avoids the heavy currents required to charge and discharge the cable. Means actually in AC system there is one very big disadvantage is that so there is a discharging of currents from the cables or lines actually. If any problems occurs or voids present, so there is a discharge may be possible in the AC transmission system, but in case of the AC transmission system it will be low, very low. And avoid also, you can avoid that problems also, right? So right, for shorter distances, a higher cost of DC conversion equipment compared to a system may still be justified due to other benefits of DC current links. So he said that just now I said that for shorter distances, higher cost of DC conversion equipment is used actually, because all the power stations we generated AC only, right? So for the AC generation, we need to convert that AC to DC. Further, to require a rectifier unit and transmit through a transmission lines and towers, and go to the distribution unit. There you should use for again DC to AC inverter unit, and further then you need to use distribution system in the appliances. All the appliances uses only DC only, right? So there is a higher cost of DC conversion, higher cost of DC conversion equipment used, but something present we need to justify that some benefits are there for DC links also. uh, you can discuss that, okay, right? And coming to next point, HVDC allows power transmission between unsynchronized AC transmission systems. HVDC allows power transmission between unsynchronized AC transmission systems. Simple point here. I discussed in the class, offline class, that there is a mock Chand project is there in Vizag. You need to you cannot transfer the directly the power line from Vizag to Orissa state, right? So there it is a asynchronous process, right? You should convert that. DC to AC line to DC, and then go to required AC line, right? You should convert that required AC line through a cycle converts anything, right? So he said that same thing. HVDC allows power transmission, that power transmission between asynchronized AC transmission means if you have any here some, here the generation that is AC, let us say some frequencies there, different frequencies there, let us say 49 point something, 49 point something, right? Right, simply I said that it is a AC transmission, right? We have the frequency, let us say 49.8 let. So this frequency should cannot match with the other states, that is other regions also. Let us say this is a southern region, let us say this is southern region, and this is a central otherwise northern region, let us say Orissa northern region, okay. So we cannot transmit that directly, this transmission directly, we cannot connect this northern region transmission line, because there is a frequency and mismatch is there. So that's why asynchronization means we need to convert this AC to DC, and then transmit that DC link, and then you go for a DC system, that is you need to convert that DC to AC, and then connect the northern region required. We can convert that we can convert we can get by using the cycle converters or anything equipment required frequency, right? So HVDC allows permission power transmission between asynchronized DC transmission system. That is the reason, right? So since the power flow through the HVDC link can be controlled independently, okay, that is of the phase angle between source and load, it can stabilize a network against disturbances due to the rapid changes in power. A simple point here, we don't have any phase angle difference or phase differences are there in HVDC link for for stability problems, right? So we can stability is very high in case of HVDC transmission system, right? HVDC also allows transfer of power between the grid systems running at different frequencies such as 50 and 60. Just now I said that this is the process, and we can transfer the power from different frequencies. Okay, so this improves the stability and economy of the each grid by allowing the exchange of power between the incompatible networks. Nothing but just now previous class I have said that there is a different regions are there, and we have different frequencies are there. We cannot connect directly to the this transmission line to the transmission different frequency transmission line, right? So that is the reason here it is very economical, and we can exchange the power from different networks for different networks, right? The power transmission. Power transmission was initially carried out in the early 880s using the direct DC, right? So previous actually present to we have AC, but previous in the first we have only used that is AC only. After that, the availability of transformers and some induction motor equipment, we go for actually in the AC system in 20th generation, right? So here are the same thing here said that power transmission was initially carried out in the early of 80s using DC only with the availability of transformers, okay, and also robust induction motors, the availability of superior synchronous generators, the facilities of converting AC to DC when required, right? So and AC gradually replaced by a DC, right? However, in 1928, arising out of the introduction of grid control to the mercury vapor rectifier around 1903. These are all the things. Okay, just he said that before first of all we have used only DC only. Just you need to set that first the transmission system is DC only, not AC. He tried to set that. Okay, right. And coming to this is the one of the most, that is uh, uh, coming to the comparison between the AC and DC transmission, right? Advantage, first of all we go for advantages for AC transmission compared to DC transmission, right? So some, first of all, technical merits of HVDC, right? So the advantage of DC link over AC links are actually the DC link allows power transmission between AC networks with different frequencies or networks, right? So which cannot be synchronized for other regions, right? So but AC link allows power transmission between AC networks with different frequencies. That is a very advantageous, right? Next, coming to, I have discussed in the just now, right? Coming to next, inductive and capacitive parameters do not limit the transmission capacity, right? So or the maximum length of DC overhead line or cable. So the conductor's cross section is fully utilized because there is no skin effect, right? Here the major one of the big advantage is that there is no skin effect in this occur in the DC transmission, not AC in DC transmission, right? So for long cable connection that is beyond 40 kilometers, already before you have learned that in the underground cables, so below 35 or 40 kilometers it is preferred for AC, but above beyond 40 kilometers, that is we go for HVDC in most of the cases after the technical solution because of the high charging current of a AC cable. So this is of particular interest for transmission across open sea or in large cities where a DC cable may provide the only possible solution, right? So because a digital control system provides accurate and fast control over the active power flow from the DC system only. Okay, for fast modulation of AC transmission power can be used to damp power oscillations in an AC grid and thus improves the system stability. Right. So the stability problem cannot occur. Right. So the stability is high in case of DC transmission system. And coming to the economic considerations, right? This is a very important. So for a given transmission task, feasibility studies are carried out before the final decision on implementation of AC and DC system can be taken. Right, coming to the figure 1 shows a simple diagram I am going to show here. So total cost and distance means so actually just before that some break even distance is there. Here I mentioned the break even distance. So up to now, if from this point distance I am telling this is the distance. Okay, so this is the cost. So up to this distance only, the cost of the AC is better compared to DC, right? After that the cost of the AC transmission is increases, but the cost of the DC transmission will be reduced from this point. Here you can say that, here you can clearly he said that from this point here, this is the point. From this point, actually initially here from this, let us say this is the distance, let us say 0 to 1 kilometer. In this point the power transmission, okay, cost is very low. Okay, right? But here the DC cost is high. Okay, similarly, same AC, that is AC cost is compared to increase up to this point. AC transmission is up to this point is okay. After that also the distance is increases. The power transmission through AC transmission is very cost, and but DC is very will be reduces, right? In the same manner also losses also. Okay, losses also. This is the breaking point. So right, this is the first of one from the first side only. So the AC, right? I'm going to here said that this is the cost and DC. Okay, right? And this is the line. DC lines, okay, na AC line. This is the AC line, and this is the DC line, right? So here this is the from this point that is as the distance increases, the line losses will be reduces, right? Line losses will be reduces, right? So this is the main important uh, topics, main important advantages compared to the AC, right? So he said that from 500 kilometers to 800 kilometers, depending on the number of factors, okay, na, like country. So this is the very less cost in case of DC, okay, from 500 to 800, right? During bad weather conditions also, the corona loss and radio inferences are lower in case of HVDC transmission line compared to DC for the same voltage and conductor size. Same voltage and conductor size, for the same voltage and conductor size. So it is corona losses. We know that corona losses and radio inferences means compared to power. There is, if there is any other lines are there nearby lines, we cannot we can face actually interference, right? So in case of HDC, it is not it not possible, right? The radio inference will be reduced, right? And coming to next one, due to the absence of inductance in DC lo inductance and property ఉండదు, ఎందుకంటే frequency, there is no frequency, right? So HVDC line offers better voltage regulation, right? Voltage regulation means from one point to another, and I mean at load side point will be high, same voltage from the sending end point also, right? So HVDC offers greater controllability compared to HVDC, right? AC power grids are standardized for 50 Hz in some countries and 60 Hz in other countries. It is impossible to interconnect the two power grids working in at different frequencies with the help of AC interconnection. Last class I have said that in the regions also I said that. Okay, so but HVDC link is make it possible because we can convert any frequency by using HVDC equipment, that is converter equipment. Interference within nearby communication lines is lesser in case of HVDC. Just now I said that. Okay, radio interferences. In longer distance HVDC transmission, short circuit current level in the receiving system is high. Longer distances, short circuit current level receiving is high. The HVAC, actually I said that HVAC, but in case of HVDC does not contribute the short circuit level, right? So power flow control is easy in case of HVDC link, and also the main advantage also there is high reliability. The reliability also consideration mainly because of two energy efficiency systems, that is two types. We'll discuss in the next next class, right? There is some disadvantages are there in the HVDC also. We'll discuss this. Converter stations needed to connect AC power grids are very expensive. Just I note that converter stations, that is rectifier station, first AC to DC. Actually generating stations అన్ని ఎలా ఉంటాయమ్మా, జనరేటింగ్ స్టేషన్స్ అన్ని ఏంటంటే ఏసీ, అవునా కదా? అవి మనం మైండ్ చేయాలి, డీసీ టు కన్వర్ట్ చేయాలి. డీసీ కన్వర్ట్ చేయాలంటే రెక్టిఫైర్ స్టేషన్ కావాలి. మళ్ళీ డిస్ట్రిబ్యూషన్ సిస్టమ్ దగ్గరికి వెళ్ళేసరికి మళ్ళీ అగైన్ ఏంటి, డీసీ మళ్ళీ ఏసీ కన్వర్ట్ చేయాలి. ఎందుకంటే we required actually AC na DC na మనకు కావాల్సింది AC, right? So the converter stations needed to connect AC power grids are very expensive అని చెప్తున్నాడు ఆ పాయింట్, right? Next in contrast to AC systems, designing and operating multi-terminal HVDC systems are complex. ఓకేనా, రైట్? అదే multi-terminal HVDC systems complex అనమాట. నెక్స్ట్, converter substation generate current and voltage harmonics, right? While the conversion process is accomplished by reactive power consumption, as a result it is necessary to install expensive filter compensation units and reactive power compensation units. So harmonics generation will be possible in case of HVDC system. సో హార్మోనిక్స్ అనే మనకు ఒక యూనిట్ ఉంది సపరేట్ గా, హార్మోనిక్స్ అండ్ ఫిల్టర్స్ అని చెప్పేసి దాన్ని డిస్కస్ చేయొచ్చు. సో అది వన్ ఆఫ్ ద ఒక ప్రాబ్లమ్ అన్నమాట. విల్ రెక్టిఫై దట్ సమ్ వీ కెన్ యూజ్ సమ్ ఫిల్టర్ కంపెన్సేషన్ యూనిట్స్ ఆల్సో, ఓకేనా? బట్ అది కూడా ఒక కాస్ట్ కిందకి వచ్చేస్తుంది కాబట్టి మనకి అదొక డిసడ్వాంటేజ్ కిందకి వస్తుంది. ఓకే, రైట్? డ్యూరింగ్ షార్ట్ సర్క్యూట్స్ ఇన్ ఏబిసి పవర్ ట్రాన్స్మిషన్ సిస్టమ్ క్లోజ్ టు కనెక్టెడ్ డీసీ సబ్స్టేషన్స్ కనెక్ట్ చేసినప్పుడు ఏమవుతుందంటే పవర్ ఫాల్స్ ఆల్సో అక్కడ ఇన్ ద డీసీ ట్రాన్స్మిషన్ సిస్టమ్. అంటే ఏసీ సిస్టమ్ సైడ్, అంటే మనం యాక్చువల్గా కన్వర్ట్ చేస్తాం కదా, ఏసీ టు డీసీ కన్వర్ట్ చేసినప్పుడు ఏసీ సైడ్ మనకి ఏదైనా షార్ట్ సర్క్యూట్ అక్కడ అయింది అనుకున్నాము, అది డైరెక్ట్ గా ఎఫెక్ట్ ద ఏసీ డీసీ ట్రాన్స్మిషన్ సిస్టమ్. ఓకేనా, అది ఒక చెప్పే పాయింట్, రైట్? అండ్ the number of substations within the motor multi-terminal HVDC transmission can be no longer than 6 or 8. So large differences in their capacities are not allowed. Actually, the large number of substations, the small may be differences in their capacities, right? The high frequency constitutes found in the DC transmission systems can cause radio noise in communications lines that are situated nearby the HVDC transmission system. అంటే అదేంటి సార్ అసలు ఫ్రీక్వెన్సీ అని మ్యాటర్ ఉంది అంటే వాడు చెప్పేది ఏంటంటే వేర్ వి కన్వర్ట్ ద డిఏసి టు డిసి, అక్కడ ఏంటంటే హై ఫ్రీక్వెన్సీ మ్యాచ్ అవుతుంది అనుకోండి, అండ్ కన్వర్ట్ చేయాలి కదా, మనం కన్వర్ట్ చేయాలి కదా. కన్వర్ట్ చేసేటప్పుడు ఏంటంటే రేడియో నాయిస్ ఏదైనా సరే నియర్ బై లైన్ కమ్యూనికేషన్స్ లైన్ ఉంటే ఎక్కువ నాయిస్ అక్కడ అవుతుందని చెప్తున్నాడు. ఓకేనా, రైట్? అండ్ నెక్స్ట్, grounding HVDC transmission involves a complex and difficult installation. సో గ్రౌండ్ ఎర్త్ మనం చేయాలనుకుంటే యాక్చువల్గా మనం ఏసీ కంటే డీసీ ఒక లైన్ తీసుకెళ్ళిపోయి ఎర్త్ చేస్తాం, త్రూ గ్రౌండ్ చేస్తాం, ఎర్త్ లైన్ తీసుకెళ్ళిపోయి గ్రౌండ్ చేస్తాం, అవునా కదా? సో బట్ ఇట్ ఈస్ సమ్వాట్ డిఫికల్ట్. ఓకేనా, ఇట్ ఈస్ an asset to construct a reliable and permanent contrast to the earth for proper operation and eliminate the possible creation of dangerous step voltage. Steep, actually once AC AC shock, okay, AC shock will be somewhat okay, but DC shock ఏంటంటే వెరీ స్టెప్ వోల్టేజ్ వస్తుంది కాబట్టి మనకి డేంజరస్ అనమాట. ఒక్కసారి DC షాక్ వచ్చిందంటే we cannot bear that shock, right? Right, this is the first topic we covered, that is advantage and disadvantage of AC transmission system, right? So coming to applications of HVDC transmission system, right? ఎక్కడెక్కడ యూజ్ చేస్తాం అనేది ఇక్కడ కాన్సెప్ట్ మనకి. ఓకే, HVDC ట్రాన్స్మిషన్ సిస్టమ్ వేర్ యూజ్ అంటే ఎక్కడెక్కడ యూజ్ చేస్తాం అనేది ఇక్కడ కాన్సెప్ట్ చూద్దాం ఒకసారి, రైట్? కమింగ్ టు ఫస్ట్ వన్ ఈజ్ అప్లికేషన్స్ ఆఫ్ HVDC ట్రాన్స్మిషన్. కనెక్టింగ్ రిమోట్ జనరేషన్ అంటే రైట్, some energy sources such as hydro, solar power are often located hundreds or thousands of kilometers away from the load centers, right? HVDC will reliably deliver the electricity generated from mountain tops, deserts and seas across vast distances with low losses. అంటే ఎక్కడెక్కడ హైడ్రో పవర్ ప్లాంట్స్ కానీ సోలార్ పవర్ ప్లాంట్స్ ప్రెసెంట్ హైడ్రో అంటే దూరం ఉంటే, సోలార్ అంటే ప్రెసెంట్ ఓకే, బట్ ప్రీవియస్ ఏంటంటే ఈ ప్లాంట్స్ మనకి ఏంటంటే ఎక్కడో ఉన్నాయి అనుకుందాం, థౌజండ్స్ ఆఫ్ కిలోమీటర్స్ అవే ఫ్రమ్ ద లోడ్ సెంటర్స్ అనుకో. HVDC will have reliable to transmission from long distances. ఎందుకంటే చెప్పిన పాయింట్ అడ్వాంటేజ్ లో ఫస్ట్ పాయింట్ అదే, లాంగ్ డిస్టెన్సెస్ అయితే HVDC ట్రాన్స్మిషన్ ఈజ్ బెటర్ అన్నాడు. అందుకనే రిమోట్ జనరేషన్ లో ఉన్న వాటిని ఏంటంటే HVDC ద్వారా ట్రాన్స్మిట్ చేసుకోవచ్చు అని చెప్తున్నాడు. ఓకే, there is a one transmission line is there from Vizag to Bangalore, right? In the మన స్టేట్ లో ఇంటర్ కనెక్టింగ్ గ్రిడ్స్ చెప్పే కదా. ఇంటర్ కనెక్టింగ్ గ్రిడ్స్ అంటే ఏంటమ్మా, సో డిఫరెంట్ ఫ్రీక్వెన్సీస్ ఉన్నాయి అనుకుందాం. ఒక రీజియన్ లో ఫ్రీక్వెన్సీ, ఇంకో రీజియన్ లో ఫ్రీక్వెన్సీ ఉన్నప్పుడు ఆ రెండింటికి డైరెక్ట్ గా లైన్ కనెక్ట్ చేస్తే ద టోటల్ సర్క్యూట్స్ బ్రేకర్స్ విల్ బి ఓపెన్, అంటే మొత్తం సిస్టమ్ కొలాప్స్ అయిపోయింది. సో అందుకేంటంటే కంపల్సరీగా షుడ్ నాట్ కనెక్ట్ దట్ one line to another line with the different frequencies, right? So connecting the AC grids, right? So during some specific circumstances the connection has to done using HVDC. For example, when grids have different frequencies or when the connection has to go long distances or water or AC cables cannot be used because of high losses, right? So that's why we go for a HVDC transmission system, right? And coming to the next one is connecting offshore wind. Means wind parks are often placed far out at sea, right? Because of wind conditions are more advantageous are there. If the distances to the grid on land exceeds a certain strength, the only possible solution is HVDC, right? Because of low losses, right? And coming to the power from shore. Traditionally oil gas platforms, that is oil gas platforms ఏంటంటే use local generation to supply the electricity to run the drilling equipment. Actually in the AC/DC నే అది actually చెప్పాలంటే for the daily need of often hundreds of persons working on the platform. If the power is instead of supplied from shore via HVDC link, కాస్ట్ గో డౌన్, తగ్గిపోయింది మనకి. ఫస్ట్ లో ఇంత ముందు ప్రెసెంట్ కాదు, ఫస్ట్ లో బిఫోర్ ఏసీ ఏంటంటే ఇదే వాడేవాళ్ళు వీటికి, ఈ జనరేషన్స్ కి, అవునా? మళ్ళీ ఇప్పుడు ఏంటంటే నెక్స్ట్ మనకి ఏంటంటే HVDC లింక్ అనేది కాస్ట్ తగ్గిపోయింది అని చెప్తున్నాడు అలాగే. ఓకేనా, రైట్? అండ్ కమింగ్ టు నెక్స్ట్ వన్ ఈజ్ DC links in AC grids. Means HVDC links within AC grid can be successfully utilized to strengthen the entire transmission grid, especially under demanding load conditions and during system disturbances, right? Transmission capacity will improve and bottlenecks the dissolved, right? And coming to next one is city center in feed. మేము సిటీ సెంటర్స్ లో మనం ఏంటంటే ఇంకా సింపుల్ చెప్పాలంటే సిటీస్ లో హై ట్రాన్స్మిషన్ లైన్స్ విజిబుల్ గా కాకుండా నీట్ గా, అసలు లైన్స్ ఏం లేకుండా, షాక్స్ ఏం తగలకుండా ఉండాలి, నీట్ గా ఉండాలంటే మాత్రం అండర్ గ్రౌండ్ సిస్టమ్కి వెళ్ళిపోవడం బెటర్ అనమాట.
ప్రెజెంట్. అందుకేంటంటే HVDC లింక్స్ అనేవి వెల్ బెటర్ కంపేర్ టు దట్ అనమాట. అందుకేంటంటే సిటీ సెంటర్ ఇన్ఫీడ్ అని చెప్తున్నాడు. అండ్ కనెక్టింగ్ ది రిమోట్ లోడ్స్. రిమోట్ లోడ్స్ అంటే ఎక్కడో ఐస్లాండ్ సెంటర్స్ అని చూసారా, వాటిని కనెక్ట్ చేయడం కూడా ఈజీ. సో దట్ ఈస్ ఏసీ గ్రిడ్ కనెక్ట్ చేయకుండా డీసీకి అయితే కొంచెం స్టెబిలిటీ ఇంక్రీజ్ అవుతుందని చెప్తున్నాడు. రిమోట్ లోడ్స్, కనెక్టింగ్ ది రిమోట్ లోడ్స్ అంటే మీనింగ్. ఓకేనా, దీస్ ఆర్ ద some applications are there for HVDC links. Okay na? Right. Coming to the next class, we go for types of DC links. Right, there are mainly 3 types are there. So that is monopolar, bipolar and homopolar links. We go for next class. Okay, thank you. We'll continue next class.